Okay, folks, we are starting our new unit. This is 4.1, so this is topic 4. This is all about systems of equations. And the idea here is that we're going to be examining graphs of a system of linear equations to find the number of solutions, and then comparing the equations to determine the number of solutions. So it's all about finding the solution. Now, what that means is that we figure out where the lines cross. That's really it. So in problem number 1, I have 3 graphs, right? And we want to draw 3 pairs of lines, each showing a different way that 2 lines can intersect or not intersect. How are each pair of lines related? Let me grab a ruler for this. Since we are drawing lines, I do want to make sure I have straight lines. What I'm going to do is I'm going to draw a line that, like, let's do pair 1, crosses here, and then, starts here at the y-intercept, and then goes up 1 and over 2, so I'll reverse it. So I've got this line right here, so that's one line, okay? And then I'm going to have another line that basically starts here as well. Actually, let's have it start here, and then goes down from that 3, 1, down 3, right 1. So that's a negative slope. The y-intercept will be off the grid here, but it doesn't really matter for this one. We're just kind of like drawing lines and seeing how they intersect or not, okay? So that's pair 1. We got one intersection. Okay, pair 2, doesn't really matter what I'm drawing here. I just want a couple lines on here. Let's do that right there. I'm gonna do this, and then I'm gonna have something, I'm gonna have these not cross. So I'm gonna have the y-intercept right here, and let's see, it's up, let's see, from here, down 3, right 2. So down 3, right 2. So I'm going to have this, and I have 2 lines here, but they're not intersecting, so there's no intersection, and so we call this relationship proportional, or not proportional, parallel. So 2 parallel lines, so no intersection. And then for this one, I'm going to have, let's just do here to here, right? And I'll have a line that goes like this, but then I'm also going to have a line, another line that basically is the same line. It just like laid right on top of it, right? So it's represented by that kind of those dashed lines right there. So what happens here is rather than one intersection or no intersection, we have an infinite number of intersections, right? Every point on one line matches every point on the other line, okay? This is the same line. Okay, so the idea here is you can have different numbers of solutions for this, right? Something like this, we have 2 lines that cross just like this. You have one intersection or one solution. When they don't touch at all, they have no intersection or no solution. Or when they're the same line, it's basically an infinite number of solutions. Okay, all right. So that kind of like leads into this one. Deanna, draw the pairs of lines below, very similar to what we just did. Although, yeah, each pair of lines represents a system of linear equations. A system of linear equations, if we kind of go back to our vocabulary right here, is just you have 2 linear equations, and it's just how they relate to each other, right? So this is all about having 2 equations, 2 linear equations, 2 lines, and seeing where they cross. That's basically the entire chapter, okay? A system of linear equations formed by 2 or more linear equations that use the same variables, so x's and y's typically. How can you use the graphs to determine the number of solutions to each system? So we have this x plus 4. This is this one here. Okay, and then we have negative x plus 6. All right, and so what we've got here, we have one solution, and we can see that they have different slopes. So let's do y equals x plus 4 right here. We have a slope of 1, and we have a y-intercept of 4. Okay, and then for y equals negative x plus 6, we have a slope of negative 1, and we have a slope of 6, right? So we can see that we have different slopes here and different y-intercepts. For this situation, really all that matters is that we have different slopes. We don't really care about the y-intercepts on this particular type of system, right? So we have different slopes. We have one solution or intersection. Okay, so let's kind of highlight that we have different slopes. We have 1 and -1. Okay. Now here we have y equals x plus 3 is this one on top, and y equals x plus 1 on the bottom. So this one, let's see, y equals x plus 3, y equals x plus 1 over here. So our slope is 1 for each of them, okay? And our y-intercept is 3 here and 1 here. So we have same slope, but different y-intercepts, no solution, or no intersection. Okay, so same slope, different y-intercepts. Now when we go to this one right here, we can actually switch this around, so it's -x minus 2. Right, so we have slope for both of them is going to be -1, and then a y-intercept of -2. So we have the same slope, same y-intercept, it's the same line, right? We can kind of just like show that by like kind of a dotted or dashed line on top of it. So we have infinite solutions. Okay, so that's the idea there. Okay. So how many solutions does this have? Well, let's take a look here. So we have y equals x plus 1 and y equals 2x plus 2. We have a slope of 1, a y-intercept of 1. I have a slope of 2 and a y-intercept of 2. So I have different slopes right here, and so that's the key right there. That's really all I need to think about, is that we have different slopes. We don't really care about the y-intercepts, but different slopes means this system has one solution / intersection. Okay, I just want to be very clear that a solution is where the lines intersect. If we were to graph this, which let's do that real quick. I'm just going to use Desmos. Get my graphing calculator over here. Okay. I'm just going to pop, let's see, y equals x plus 1, and then y equals 2x plus 2, right? You can see that there are different lines. We have an intersection right here. So yeah, for this, we're talking here, we're just figuring out how many solutions they have, right? For the first three. But for this one, we've got an actual word problem here, so we can figure this out. So Harrison and Pia each buy X comic books. Harrison also buys an action figure for 15, while Pia buys a different action figure for 5. Could they each spend the same amount for comic books? And we can see this little graphic that's comic books are each $5, right? So that's that 5 right there, 5X, where X is the number of comic books bought. Okay. And then we have Harrison with the action figure, the first action figure, and Pia with the other action figure. So Harrison here and then Pia here, right? So for Harrison, we have a slope of 5 and then a y-intercept of 15. And then for Pia, we have a slope of 5 as well, and then a y-intercept of 12. So we have the same slope, but different y-intercepts. And so we kind of go back here to this one, and we see same slope, different y-intercepts. We have parallel lines, so there's no solution, right? So we would say, yeah, same slope but different y-intercepts means they can basically never buy this, or they would never spend the same amount of money, right? Since they're let's see, since the slopes are the same and the y-intercepts are different, they could never spend the same amount of money. Let's see, and I'll summarize in a different way in a second. Amount of money. So basically, right, if they each buy, 4 comic books, right, if they buy the same amount of comic books, Harrison is always going to be spending more money because his action figure is $3 more, right? So his total is always going to be $3 more as long as they're buying the same amount of comic books, right? Because it says that they buy X, so they buy the same amount. So yeah, estimate solutions of systems by inspection. Corey and Winnie each bought X pounds of cheddar cheese and Y pounds of tomatoes. Corey spent $12 at the supermarket. When he spent 24 at the farmer's market, could they have bought the same amount by weight of cheddar cheese and tomatoes? Explain. So these are the prices here for each one. So let's see, Corey is right here, and then Winnie is right here. So those are the equations that represent it. Now this is called standard form, and it's different than slope-intercept form. Okay, standard form is going to be AX plus BY equals C, and then slope-intercept is what we have traditionally used, that Y equals MX plus B. Now, these are just different ways to represent linear equations. These both are lines, right? And you see that they both have X's and Y's in them, right? We can actually convert from standard form to slope-intercept form. And it's the same step each time, okay? So bring the X term to the left side. So I'm going to subtract 6X, right, to get to 2Y equals negative 6X plus 12. I'm going to do the same thing here. Subtract negative 12 to get to, oh, that crosses out. So 4y equals negative 12x plus 24. And I'm putting the x first because in slope-intercept form, my x term is first, right? And then I'm going to divide by the coefficient of the y term. So I have my coefficient right here of 2. I divide by 2 on both sides. Give me just a sec here. Let me pause it. Give me 1 sec. How do I pause here? Oh, come on. Gosh, I hope this is recording. Okay. So we are dividing by the coefficient of the y term, so those get crossed out. So we're left with y equals, let's see, negative 6 divided by 2 is negative 3x. 12 divided by 2 is 6. Negative 12 divided by 4 is, oh, look at that, negative 3x. 24 divided by 4 is 6. So we have basically the same equation here. Could they have bought the same amount by weight of cheddar cheese and tomatoes? Yes, they could have, because it's the same line, right? So basically these are infinite solutions because it's the same line. Let me real quick get my Desmos again. I have to boot it up because I had to reset my computer. Right, I'll pull that over here and I'll put the original equations in. Let's see, 6x plus 2y equals 12, and then 12x plus 4y equals 24, right? We can see the same line. I'm actually going to show this one as dotted. So like you zoom in, you can see that they're both the same line right there. So yeah. So you'd say yes, it is possible that they bought the same amount of stuff. Because they have the same slope and same y-intercept. They have the same slope and same y-intercept. Okay. So spiral review, this is on the test, right? You're going to be tested on whether functions are linear or nonlinear. So the idea is you figure out you're changing your x's, changing your y's, and you have the same number, then it's linear. So we're adding 2 here each time, and we're adding 1 here each time. Same number, so it's linear because it has a constant rate of change. And then we look here, we're adding 1 each here, and we're adding 1 here and 3 here. So we have a different number here, so non-linear. nonlinear because it doesn't have a constant rate of change. All right, there we go. Hopefully that